There we go.
Yes. Are we there?
Is he live?
Yes.
Okay, we're good. I think we're good now. So want to get started? Let's wait for like a few minutes for people to join in.
Yeah.
Just in case people are late.
So Santa brought us a 0 day. Does that mean we were naughty, or is there like a bright side to having a 0 day?
I don't think it's a good thing, honestly.
Not a good thing? No? Okay.
Yeah.
But he brought it to like just about everybody, right? So isn't it? I don't know.
That's a good point. It's probably the threat hunters, the red teamers, and the bug bounty hunters are good this year. That's why.
Yeah. It depends on what's good and what's not good. Like from one perspective, it's good for somebody, and then it's not good for the other folks.
I was just like having this conversation with a friend yesterday, and we're talking about like how, because this vulnerability is so ubiquitous, basically everyone is like impacted, right? Even though you are an attacker, your own systems might be vulnerable to the vulnerability too. So
yeah.
it's sort of like a free fall for all kind of vulnerability, free for all. Just attack everyone with it.
Yeah, this one has all the points which make it severe. It's easy to attack, easy to propagate. It's everywhere. So yeah.
Do you think a worm is gonna be developed using this vulnerability?
I'm pretty sure they're already there.
Really?
Yeah, they must already be there, running through, searching through botnets, and trying to find hosts.
Dang. Okay. I think we should get started on the actual presentation. Hi, and welcome to the session, everyone. Thank you for joining us for this discussion on Log4j 2 vulnerability, also called Log4Shell, because I assume you get a shell from Log4j. So as you all know, something really, really crazy happened in the InfoSec world last week. Right? By now, you've probably already heard it's an unauthenticated RCE in the critical Java logging utility called Log4j. And today we're going to discuss about it, right? We're going to give you like an overview of what really happened last week. We're going to dive into how the attack works in detail and how attackers can achieve RCE with the bug, as well as what they can potentially do within the systems that they attack. So we're going to talk about the bug's impact and how you can mitigate it in your own systems. We will also talk about managing open source vulnerabilities in your applications, as well as how to determine if your organization is vulnerable to the Log4j vulnerability. So let's get started. First of all, just like a recap of what happened last week, right? So in November, a Chinese researcher privately disclosed to Log4j maintainers that the Java library, particularly the version 2, contains a very critical vulnerability that allows for unauthenticated RCE in applications that utilize the library. So because it's a very critical vulnerability and affects most Java applications, it needs to be dealt with carefully, right? That's why the researcher disclosed to the maintainers about, I think, late November, like a week before December, to the maintainers, so that the maintainers can have a patch ready for when this vulnerability is publicly disclosed. And on last Thursday, which is December 9th, I believe, this vulnerability was officially disclosed to the public. And I think it has something to do with Minecraft, right? Suchakra, do you know exactly what happened with the Minecraft?
Yeah, I think someone found out that the folks who realized that there's a vulnerability in Minecraft, vulnerability in Log4j, they also knew, like, it could be just some high school students, who were poking around, and they realized that Minecraft is also Java. So, they must have poked around and found out, yeah, it's using Log4j, and try to just own it to get some points or something like that in their servers. So, that's how it's like public awareness gathered from that moment, actually, because it's like a fun thing, but also dangerous at the same time.
Was it after the patch was made available or before that? How did the Minecraft people find out about the vulnerability?
I really don't know. Maybe like the patch was made aware, and once they found out that the patch is there, they realized what the vulnerability could be, and then probably they try to retroactively like hunt around, on Minecraft servers. Like I mean, the timeline is not too clear to me, but probably like the patch happened before the actual people who started to own it, because not everybody patches very quickly. So the delay is too high. Like there will still be servers. So they were probably just looking at, hey, let's try to own Minecraft and see what happens.
So did they just start like firing payloads at each other?
Yeah. That's possible, because it's easy to detect open LDAP servers. Like 389 port for LDAP is like standard, and they would probably try to do some sort of port scanning on remote servers, and then try to see, okay, which version of Minecraft is running, and then does it have what Log4j could have been inside it, and they would try to do all these sort of things to understand whether it's vulnerable or not, and then fire payloads.
Mm-hmm. Oh, wow. That's crazy.
That's the new meta for Minecraft, I guess.
Yeah.
Yeah, so
at least, I mean, people are using Minecraft for education, for kids. So this is like infosec education with Minecraft.
Oh yeah, exactly. Yeah. I originally thought that the vulnerability was disclosed by the Minecraft people, but apparently it was privately disclosed. That's why a patch was available so soon after the public disclosure. And yeah, so this vulnerability has been dubbed Log4Shell because you get a shell from the Log4j library, and it has been assigned a CVSS score of 10.0, which is the highest possibility for vulnerability. And it's sort of the score is that high because of several reasons, right? So first, it's very easy to exploit. Like the attack simplicity is very low, and you don't need to get authenticated in order to exploit it. And as well as, I think there's some other factor that determines the CVSS score. And in every single factor, this vulnerability scores in like the highest category. And this vulnerability is especially severe because so many applications and so many organizations depend on the Log4j library, right? And all of these applications can become vulnerable because of this bug. And this vulnerability will allow attackers to execute arbitrary code on all of these target machines potentially. I remember like when I was browsing my own example code or example applications I built with Java, and all of them were using Log4j actually. And so this just goes to show how ubiquitous this library is and really how big the issue is. Beyond what the CVSS score says, right? The CVSS score just says how severe this particular vulnerability is outside of its context of its real world impact, where we are seeing that Log4j is a very severe vulnerability and its real world impact is also very, very high because of its extensive usage. And so, as I said, because this library is so ubiquitous, many organizations were actually confirmed to be vulnerable, right? Companies like Apple, Cisco, Microsoft have all confirmed that their product was impacted. And many open source projects are affected too, right? Like the Apache struts, for instance. And basically, any applications that were using Log4j version 2.0 to 2.14 are affected. So 2.14 is like the latest version before the patch was released last Friday. and any applications whose dependencies use these vulnerable libraries could by extension be affected too. And so on this slide here, you can see like this GitHub link. This is a CISA assembled list of all the vendors that are vulnerable to the issue. And it also shows like where the vendors are in terms of mitigation as well. And you can see that a lot of vendors have started to patch their products, and a lot have already done it, but many are still lagging behind, right? Even for the organizations that we traditionally think of as very secure are having trouble containing the damage. And in terms of like impact of how the vulnerability has been exploited in the wild, organizations have been monitoring their systems, and they have discovered that the vulnerability has started to be widely exploited in the wild ever since a public weaponized POC became available on December 9th. And organizations have even found that sort of signs of exploiting this vulnerability has been appearing since early December, even before the vulnerability became public knowledge. So, and at this point, it's mostly being used to deploy crypto miners in the wild. There has also been attempted data theft and lateral movement into organization networks, and state-sponsored attacker groups from North Korea and I think from Russia has also been detected trying to exploit the vulnerability. So basically, this is what happened, right? A very, very widely used a very, very widely used library that is essential in a lot of modern applications became vulnerable, and as a result, many, many applications that rely on it are vulnerable at the moment too. And so let's now dive into how the attack works, right?
Yeah.
I think Suchakra, you're going to give us like an overview of what makes the attack possible, how JNDI works, and how it relates to the Log4j vulnerability.
Yeah, sure. So let's first look at the building blocks of this vulnerability, because there are multiple factors. So as you just saw the slide before, modern infrastructure is built with many of these small blocks all over the place, and one of these blocks is Log4j. And the thing which makes this vulnerability very, very dangerous is because this is ubiquitous. As Vicky was explaining, in our own code, just example code that you're going to write, you're going to use loggers, and the first logger that you would use is Log4j, and this is for Java applications. And what makes it more dangerous and the impact becomes very high is because this has been there for ages. I remember the time I started learning Java, Log4j was still there, and it has been there for quite a long time. And therefore, all the enterprise software which is still running heavy Java and all the legacy stuff, it is all having Log4j in them. So all of it is affected. At the same time, older technologies which have been there, other building blocks, as you can see, they have also been in the system of enterprises and in everyone who is using them. So the first block is this Log4j. It's very straightforward. You import Log4j logger like this. You would have to include it in your build system some way. Like if you're using Maven, so you'll have a POM file which says, here's a dependency, use Log4j version, block com.apache.org.apache.log4j.core or something like that, and give it version number. So the version number could be 1. So if it's 1, you are okay. It's not dangerous. Because the features which are affecting the vulnerability to be manifested were not added beyond 1. So there's a meme which says, "Oh, I never updated from 1, so I guess I'm secure." So it's kind of like a weird thing as well. But from version 2.14.1 below, they are definitely affected. The first patch got released for 2.1.15, and then 2.16 is the one which I think is okay for now. So how it works is you include it in your dependencies, you import it, you initialize the logger, and in your application everywhere, you'll just have to use log.info and then a string that you will specify. There are a few things in log4j. So here you can see that log.info, and I'm giving it a direct string here. It will take this string and just print it in the console when the logging happens. You could also replace this string with a syntax that Log4j uses, which is like dollar and the curly braces and a variable name and then curly braces closed. In this way, you could replace the string with something else that can happen, and we'll talk about it later. So the other component which is very important in this vulnerability is this thing called JNDI. Again, just look at this diagram. It's from the 90s. It's not even a modern diagram, and that explains where the problems are lying, because these are older technologies, but they are very useful technologies. So this JNDI, Java Naming and Directory Interface, it allowed the Java application to basically communicate with various other services, other implementations like LDAP, NIS, RMI, etc. And all the application would have to do is, it provides like this abstraction, an easy abstraction. All the application would have to do is to use the JNDI APIs, and you could directly use, for example, LDAP, and communicate with the LDAP server, fetch objects from the LDAP server, and then use them inside the application. So this way, this was an interesting, technology at that time. But things have moved on. It's not like really ready. It's not secure enough. Many things have existed in this code base, and nobody knows what is going on. There are some implementations, I'm pretty sure, in enterprises which are not even aware that they must have been having LDAP servers running, which are fetching things. And some are so much embedded inside these enterprises because it makes more sense when in enterprise, this type of technology. And they might just have it in the system and they cannot replace them because the business logic is too much dependent on LDAP, for example, to communicate via the JNDI APIs. So here's like a real example. So on the left, you see your application, and your application exposes an API. So let's assume it's a web API, and the application gives you like a nice web form. And this is like, there is business logic in it. And it's on an internal network, and it's for employees who want to access something from the database of other employees, information of other employees from a database. Let's assume this application does that. So how enterprise would structure the data transfer from the application would be probably through a JNDI interface, which can then talk to an LDAP server, and LDAP server will fetch all the objects like who is the person. It's the request is like, okay, I have an email, john@company.com, give me all the information who this person is. And that communication would happen through the JNDI interface, and it makes things easy because the person who is developing the application only cares about this business logic of the application, whereas all the underlying infrastructure where the database of the company folks resides is somewhere else. It could even be on different servers altogether. So in a large enterprise, these kind of things make life very easy, and at least at that time, it made the life very easy of folks. But also it exposes a lot of bugs in the process, because any bug in the application and through the JNDI interface or going all the way to the LDAP server can cause havoc, and that's what exactly happened in this case.
Mm-hmm. Are there any like modern alternatives to this functionality for Java?
Yeah, I don't think so. LDAP servers are still quite used in multiple places. I mean, sometimes in big enterprises, that's the only way to have authenticated access to underlying resources. So they're still being used, at least if Java is implemented at enterprise level. Other ways could be to roll your own kind of thing, where you have a company database and an internal, service which is written in much more modern way, and then you manage it like that. But companies which completely switched over to Java and adopted it as the central tenet of their infrastructure, they would probably use this, and it's a solid implementation because with this application and the JNDI interface, you could not just connect to an LDAP server, you could connect to RMI, invoke objects in another server somewhere, okay, or other DNS queries. Like you could think of it as like Java providing lots of these Lego blocks which fit together in enterprises, and you don't have to craft your own Lego block in your 3D printer. That's not what they were aiming for. They provided these blocks, and you could extend them as much as possible. But at the same time, you could just connect to anything. The security was not too high. It used to be quite high for that time, but now things have changed a lot.
Mm-hmm.
So as I explained, JNDI provided an API to interact with remote objects. So a Java-based application could use JNDI plus LDAP and find business objects such as the details of an employee in an organization, and the LDAP server could be running on a different protected zone somewhere else. So kind of like provide a layer of security between any third-party directory. User directory or a company directory versus the actual data that is stored. So providing some sort of security by creating like a protected zone. So that was a nice technology, and that's what it was.
Mm-hmm. All right, thanks for that overview of JNDI Tracker. I think that's very, very helpful for what we're going to talk about next, because we're now going to talk about how the Log4j attack works, right? And the issue is exactly that. The issue that causes RCE is that Log4j actually supports JNDI lookup. So Log4j supports many other types of lookups too, which you can find in this link right here. But for the purpose of understanding the Log4j vulnerability, you just have to know that Log4j supports lookups in this format, right? So $, and then curly brackets. In the middle is the prefix, and then the name of the lookup, where the prefix is actually one of the different numbers of lookups that Log4j supports, and the name is the resource that you want to look out for, or the resource that you want evaluated. So for example, if you say to Log4j, evaluate $ curly bracket Java version, then it's going to return the current running version of Java. But at the same time, you can do something more interesting with these kind of string lookups in Log4j, right? If you can submit this string, for instance, to Log4j, it will actually perform a JNDI lookup to this LDAP server and load the Java code that this server returned, and then make it run on the target application. So this is like the entire reason that this RCE is happening, right? Log4j being too permissive in what its lookups will do, and as well as the wide support of JNDI lookups and the lack of whitelisting or lack of protection in what an application looks up for. And so let's break this a little bit down into a step-by-step process of what happens when someone attacks an application using Log4j. So first, the attacker will inject the malicious JNDI LDAP URL into the application in any input field that gets logged, right? So this could be like a user agent header. This could be any other kind of headers or request parameters that will eventually be written into logs and therefore processed by Log4j. And then this URL, the attacker will put in the location of their server. And then Log4j will parse the JNDI URL, and the vulnerable application will reach out to the malicious LDAP server to look for the exploit payload object. And then the attacker's response will contain a path to another remote Java class file, which will then be injected into the application's process and then executed by the application. And at this point, the attacker can make the application run whatever Java code that they want and achieve RCE on the machine. And so now let's take a look at sort of what a piece of code that is vulnerable to the Log4Shell vulnerability would look like. Can you all see my screen properly?
Yeah.
Okay.
Yeah.
I noticed that the code is like quite difficult to read here, but this is like a very simplistic example that this application is taking an HTTP response from the user and then logging specific pieces of information, right, from the user. And you can see here that the application uses Log4j to handle logs. And the application takes in user input and then extracts the username and the user agent request headers. And then the application logs that into logs without any changes or any sanitization to the user input on line 23 and 24 respectively. And so this is where the attacker can use the Log4j to attack the application, right? They can inject the malicious lookup string into the username or the user agent request headers. And once it gets processed by Log4j, the whole process that we just talked about is going to happen, and they can run whatever Java code they want on your application. So it's really quite simplistic to execute the attack, and all you have to do is to input the string as well as host the Java class file remotely, right? So now we're going to have Rob show us how you can determine whether you're vulnerable to Log4Shell or not. And then after we see how you can detect it, we're going to come back and talk about some mitigation tips as well as some lesson learned from the Log4j vulnerability.
Thanks, Vicky. Let's see, do we see my screen yet?
Yes, your screen is up.
All right, great. So as Vicky said, we're going to take a look and see how we can detect Log4j in an application here using shift left core. So to start, I'll go in and take a look at an application where I've gone ahead and added a vulnerable version of Log4j. And so we'll go in and go to the open source vulnerability tab. And I'll just go ahead and start searching for it by name, and we see it pop up right away. And this is the vulnerability. We also see the CVE number, and I could have searched for it by looking for the CVE number. We see the common vulnerability score, which, as Vicky mentioned earlier, is at its max at 10. And we see common weaknesses associated with the vulnerability. When we click on it, we see a description, and then we see some remediation advice, which Suchakra will be going into in more detail soon. As an added bonus, we can also see when shift left first detected Log4j in a scan. And I can do this by going up and switching the scans. So by going to an earlier version, I see that it wasn't there. And that scan 2 here on the 16th at 4 p.m. was in fact the first time that it was detected by the tool. So now let's say we want to confirm we've upgraded and we want to confirm that we're using the appropriate version of Log4j. In that case, there's not going to be a vulnerability associated with it. So it's not going to be here in the vulnerability tab. So what we want to do there is take a look at the software bill of materials. And so to do this, I'll go ahead and take a look at another app that I have upgraded to the appropriate version. I would go to the reporting tab at the top. I'd go to open source vulnerabilities on the side, and then I would scroll down through the bill of materials until I find Log4j. And here I'll see that I'm using version 2.16. I'll see that there are no vulnerabilities associated with this version, which is what's expected. And I'll see that it was first seen in the app about a day ago. So there we were able to see how easy it is to detect Log4j, how we could go back through versions of the scans to see when it first appeared by shift left core, And we saw how we can confirm that we're using the appropriate version by consulting the bill of materials. Any questions, guys?
No, I think this is pretty interesting and straightforward, I would say. And it's one of the easiest ways, if you're using shiftleft at least, to understand whether, because shiftleft does intelligent SCA, so it will find whether you are using Log4j in your systems, as Rob was showing in the first tab, but also give you the version name. And it then correlates it with existing CVs against that version number. And it would just show you that, okay, this one has a vulnerability. And the moment you upgrade it, things change, because now you no longer see the vulnerability, and you can look at the SBOM and find out that, yeah, you definitely upgraded to the good version.
That's right.
I think this is also actually a good time to address one of the questions in the comments. So sudopriv said that, how can SAS detect a JNDI URL string injected into the taint flow to log statements? Of course, we can begin to validate every single string injected, but this can cause severe latencies and cause performance issues in the scanner, right? So what is like a good way to do that in terms of static analysis?
Yeah, so I think one thing which I would like to point out here is that static analysis is not interested in parsing each string that comes to it. It's interested in giving you an understanding that there is a string which is attacker controlled, and it is going to log4j, and you are using this specific version of log4j, and hence, because these two of these points are checked, that there is an attacker control variable going all the way down to log4j sync, which is like log4j log.info, and then a string like a var, and this var is attacker control. That's first point. And second is that since you're using this log4j thing for logging, and the version is less than 2.14, you are 100% affected. The attacker is 90% of the time you are getting good strings from your attacker control server, but only this, like 99% of the time, it's all working perfectly. But you need only that 1% where one of the attackers is going to find your server and just put in the exact string, and then you're done. So in that sense, a true finding of the vulnerability and a true mitigation has to start all the way from the left, where you understand that a vulnerable library is there, and that vulnerable library is used, and it is attacker controlled. So doing this on the left saves you a lot of time by parsing strings and like live patching somewhere at runtime.
Mm-hmm. So I think there are security solutions that work in the way that they're actually parsing the attacker's input and then sort of deciding whether it's malicious or not. Like a lot of WAFs work that way, like web application firewalls. But in terms of static analysis, you're more interested in whether the vulnerability is there or not. Right? You're not actually working on the level where you're deciding whether a single piece of input is malicious or not. You're actually determining whether any attacker can attack this vulnerability or not. And there's another question from sudopriv actually that I think we can briefly discuss. He said that if we are parsing the attacker's input and determining whether it's vulnerable or not, where should the validation occur? At the edge or within the application itself?
So I think, again, like if you want to really parse at runtime the attacker inputs that are coming in, I would say it's better to, so there are multiple ways you can approach this. So if I recall, AWS released like a Java agent. So in Java, there's a technology called as Java agents, which can hook onto live applications. And with those, you could actually do this live in the application context itself. You would not have to have some other third-party thing running. In another way, you keep the application aside. You do not parse it inside the application context, but have like a firewall, which is trying to parse all the incoming requests that are coming in, and then once you see something who is trying to attack, you basically just block it. So in that sense, if you're using AWS and you have an API gateway, you could use some like a firewall with API gateway. I think I forgot the name of a very simple firewall that they provide if you use AWS API gateway, but you could basically parse your strings there itself, and you don't have to touch the application. It will just block it at that level. So in that sense, it is like on the edge and not exactly inside the application.
I do think as I think I saw yesterday that like a lot of, I think it's Cloudflare or something like that, they're providing like a temporary patch for everyone for to prevent attacks that contain log4j attack strings, which I don't think is particularly like a comprehensive solution.
Yeah.
It's like temporary, right? Because there's always going to be more sort of like mutations of the attacker string.
And also I think there would be places where there are real use cases which will get impacted, like which is not an attack, but it gets wound up inside this string matching and parsing which is being done. And some applications might lose functionality, and then you wake up someday, you're trying to find your friends in your company's directory, and then suddenly it stops working. So what I'm trying to say is that that's not always the case. The patches are important to be put out there for at runtime also, like runtime protection, but the actual mitigation is going to happen way more in the left side.
That's for sure. Like if you want your applications to be completely secure, even considering the edge cases or like any kind of new attack string that attackers can come up with. So there's another question, this time from Tomesh Sahu. How do people go after a particular application or a target to sort of find whether it's vulnerable to Log4j? Is that what you're asking?
Yeah, I mean, it's tough, but I mean, I wouldn't say it's tough, because all you have to see is like look at open ports, find out if it's running, some RMI service or LDAP, and then if it's Java, then see it's possibly using Log4j, and start putting in these attack strings inside. So because what a lot of Java developers, like, think of it like we'll keep the same example that we are discussing, like a form which has like these inputs, and in the inputs it's like email of a person, and the response of that form is the name of the person and their details, etc. And it's a company directory internal, and somehow it is also externally provided, it is hosted. So if you have that form, there is a high chance that there is a developer who was creating that form. They have used Log4j to just log in these inputs which a person is sending, or transforming them and then logging the inputs which the person is sending. There's a high chance, because all these logs look very non-threatening. They are just appearing in the console of the app, which is all very internal. Sometimes people might use these logs to use for telemetry purposes also, and to find out what's going on in the app. So there's a high chance they are logging all these interesting things for their internal use. And that's where the problem arises, because with this simple attack, anywhere the app is running, that infrastructure can be directly compromised. So yeah, you would look for open ports for LDAP servers running in the same app, or around the same app in the same context. Just try to give input strings. It looks like the way people would do SQL attack these days. Try to do that, or XSS. It would look very similar.
I guess a related question that I could think of is that when you look at a target application, that you are helping audit or you are helping defend, how do you find out whether it's using the vulnerable versions of Log4j in the first place?
Oh yeah, so that's what we'll cover in mitigation. So maybe let's go to the mitigation slide.
Sure. So yeah, let's talk about how you can mitigate Log4j vulnerabilities in your applications. Suchakra?
Yeah, so I think the first thing that you would want to see is that what version you're using. So let's assume you're using your Java jar, which is supposed to be deployed, is built using Maven. That's one assumption we can take. So what you'll do is you'll see the pom.xml and see the dependency strings in it, and then there's a version number in the pom.xml, and you have to see that it should be more than 2.16, because like even 2.15 has issues now. So make sure that the version number is upgraded to 2.16 and rebuild the application. That's the first thing. If you're using Gradle, it would be a very similar thing in the Gradle file or any other build system. Just make sure that the versions are upgraded to 2.16. 2.16 is completely disabling the JNDI lookup already. So the feature is gone from 2.16. So that's the most safest way, I would say. And to see if you're using like the JNDI lookup in your system, you would probably just remove the whole class which is causing JNDI lookup. So you don't want to upgrade like a lot of things. So what you can do is take the log4j classes. You don't want to, so let's assume you don't want to upgrade it, but you want to just use everything as it is. So the best way is to look at the log4j jars which have been deployed, and then just remove the JNDI lookup class. So you would use zip-q-d and take the log4j classes and take the log4j jar and then look up this class and like remove it from there. So that's one way to do it. Install the updates from vendors. So log4j is being used transitively a lot in almost all the applications. So even if you remove it from your app, maybe there is a third-party vendor you have used, they might be having log4j, which is an older version. So try to upgrade as much as possible anytime an update comes, because that's the most important thing. And the third is like look for signs of compromise. So keep on monitoring the systems. Anytime some data exfiltration things are happening, obviously you'll have to look at runtime, what's going on. Are there spikes in the system, or some random processes are being executed which are not supposed to be executed? You could use that. Other ways to mitigate is to remove permissions from the application. So for example, like the Java application cannot spawn any other process. So when you run an application, you could use seccomp or other runtime techniques to kind of like enclose them in these jails, so they cannot execute any third-party process, or they cannot communicate over network on this particular port. So you could try to have these policies set up on the application itself so that the applications get secure. And one more thing which I would like to say is, this is much more general. It's not related to how you can save your system, but it's more, I would say, like a philosophical thing that people should do is to please contribute money to open source software, because why this vulnerability has occurred, people are not asking. The situation is that there are a lot of open source software which is out there, and everybody is just jumping on using them, but you need to contribute back, either in terms of money or in terms of actually helping develop them. So this needs to be there, and it needs to be done industry-wide so that things become more secure.
That's for sure. Also, on that point, I also know that there is a bug bounty program, like the Internet Bug Bounty Program, that rewards anyone who finds vulnerabilities in these essential infrastructure, right? I think it's on HackerOne. So if you're interested in contributing to the security of open source projects, you can also check that out. It's a way that you can earn a little bit of money by securing open source packages. So yeah, on that note, Is there any more questions that you guys have, or any comments, or anything else that you want to talk about? If not, I think we're going to conclude our live stream at this point then. Thank you so much, everyone, for joining us. This was really fun. And thank you so much, Suchaka and Rob, for a very detailed technical deep dive of Log4j. And thank you, Rob, for the demo.
Okay, thanks. It was my pleasure. So stay safe, folks.
Yeah.
Yes.
Happy holidays.
And patch to 2.16.
Yeah, please patch to 2.16. Yeah.
All right,
Okay.
bye, everyone.
Bye.